My name is Tristan, and this is my presentation. I'm going to try to briefly go through some of the advancements that have gotten us to our modern day in science. And here's a quote from Isaac Newton. Basically, no matter how great you are as a scientist, you still owe most of what you know to your predecessors. So ancient theories, we start with the ancients, of course. And these are the Platonic solids. They were discovered by Plato as the only regular convex polyhedra. And as a fun fact, Earth, the cube, is the only volumetrically tileable thing. So basically, there's no negative space when you put it in a volume. All the other ones don't have that property. So Plato would agree with Aristotle about the geocentric model. Aristotle had a few beliefs like that the Earth wouldn't rotate, it was at the center, and all orbits were perfectly circular. And he also had some faulty ideas about gravity. And then we continue to medieval philosophy. So Copernicus of the Holy Roman Empire, he created the heliocentric model, which shows that he still had circular orbits, but he put the sun in the center. And then Brahe was one of the best observational astronomers of all time. He sighted the first credible supernova and created very intricate data tables that Johannes Kepler would use to devise his new and corrected orbits, which would use ellipses instead of these circles. And he was the first person to break that dogma that prevailed since Aristotle. So Galileo, he disproved Aristotle's faulty ideas about gravity using balls on a slope. And he also observed a moon going around Jupiter, and he saw that not all orbits orbit around the Earth. Which, if the Jupiter has a moon, then obviously Earth is not at the center. So we continue to Isaac Newton. So Isaac Newton, he created this equation for gravity, which we do use, and he famously and apocryphally devised it when he saw an apple fall from a tree. We don't really know if that's true or not, but it's a nice story. And of course, he created all this free body motion, but he was also involved in astronomy, of course, with his idea of gravity. So we continue to more modern science, and this is where it'll blow your mind up. So Einstein, using the invariance of the speed of light, he proved that all motion is relative. So basically, he modified all the equations to make them more precise. Every single equation we use is actually incorrect in this class because we don't calculate relativistic velocities. And Hubble, he saw that all things were redshifting away from us. All galaxies were redshifting away from us. At first he thought, why is everybody going away from us? Like, what is so scary about the Earth? But actually, the galaxies, the entire universe is expanding, so everything is shifting red, and the red shifting is a phenomenon that's a little bit more difficult to describe, but basically, as you saw the electromagnetic spectrum in other slides, it's red shifting away from us. In any case, that brings us to the modern day, and that is my slideshow.